Okay. Sense for that one. Did this one make sense? Because I know sometimes when it's asking for two different things, it kind of gets confusing. So, did everybody understand this one, how to do it? Okay, so when you have it's asking for something or something, you can honestly break it up into two different problems, and then that would be kind of confusing. Let me think of a different way to say that. You just look at it as like different entities. So like the first one, they wanted a probability of a multiple of 3. So I need to look over here and see, okay, how many multiples of 3 do we have? I wrote down the multiples of 3. So let's look. 3, 6, 9. So there's 3 chances out of the 16 that I would get a multiple of 3. And it's saying, or I can get a vowel. So let's count the vowels. Vowels A, E, I, O, U. There's an A and an E. So there's only 2 chances out of the 16. So that's why I wrote the 3 right here and the 2 right here. And you just add them together because you can have either this or this. So add them together and then over 16. Like on this one, how we did the shaded, we counted the shaded and we put it over the total amount that you could get. You're doing the same thing here. You're just kind of doing 2 of them in one. I hope that helps. Now it's wanting a perfect square. So we have to know our perfect squares. So the square root of, let me put it in the calculator so that you guys can see it. So a perfect square just means that the square root is an even number. So square root of 1 is good. You can do all the numbers, but you'll see square root of 2 is not a perfect square root. Neither is square root of 3. Let's look at 4. Okay, 4 gives us an even number. So let's be writing these down. So I know 1, 4, because 1 squared is 1. So that's how 1's a perfect square. Then 2 squared is 4. So let's see what 3 squared is. 9. What's the square root of 9? 3. So 9 is a perfect square. And then it only goes up to 10. And I know 10's not a perfect square. So 1, 4, and 9 are the only ones that are perfect squares. So, because it only goes up to 10. If there is a 12, I believe 12. No, not even 12. Not even 12. I don't know what I was thinking. So 3 out of 16. So that one involves you knowing what a perfect square is. I hope everybody knows what a perfect square is. And I know a lot of you don't have a calculator like I use during these reviews. On your phone, I'm more than positive there is a square. Like if you unlock your phone, if you have it locked, turn the calculator to the side, it has a square root option. So, or Desmos, that's what they're recommending y'all use is Desmos. If you type in Desmos scientific calculator, it will come up. Okay, so the next set of problems. A card is drawn at random from a standard deck. I need you guys to remember a standard deck has 52 cards. And it says, what is the probability that it is a club or a red face card? So let me type in standard deck of cards. And you guys can do this on the deck of cards. Okay, so as you see on my screen, now let's see. So the question was the probability that it is a club or a red face. So remember what I said about the last problem, when you have two and it says or, just kind of look at it as separate things. So let's do the probability that it is a club. How many clubs are there in a standard deck of cards? Can someone tell me? How many clubs? Should be 13, right? So in a standard deck of cards, there are 4 suits. You have the clubs that are right here on the top, spades that are right here in the second row, the hearts, and then the diamonds. Each suit has 13 cards if you count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 cards. There's ace, 2, 3, and so on. So the probability that you would get a club is 13 out of 52. But I'm not going to write that because remember, we need to add them together. So 13 for getting the club. And then it says a red face card. A face card is like king, queen, and jack. So how many red face cards do you have? Hold on. Y'all tell me, how many red face cards do I have? I was trying to tell you to go away because I was on Zoom. Okay. How many red face cards? No one has said anything in the chat box. I'm honestly just about to stop because no one's responding except for like one person. Yeah. I feel like a lot of y'all have turned your cameras on and then walked away from the camera. Can I see everybody's face? I see, like Karen's, and I know Maury's answering. I just want to make sure y'all are there. Because I really don't like talking to myself. It just makes it way longer because I have to wait 5 minutes for responses.
Can you repeat that one more time?
Yeah, the question I asked was how many red face cards. I've gotten one correct answer. So I'll go ahead and there's six red face cards. Of the hearts, there's 3, and there's 3 diamonds. So I'm gonna stop sharing my screen now so you guys can see my work. So we put 13 underneath the clubs, right? Because we said there were 13 clubs. And how many face cards that are red? 6. So now we just add these together. 13 plus 6 is 19. And I said at the beginning, you have to remember there are 52 cards in a deck. So that anytime they're talking about a deck of cards, 52 should be the bottom number, unless it's like simplified. But 19 and 52 don't have anything in common to simplify it. A 2 doesn't go into 19 evenly. 3 doesn't go into, so this is the answer. Did that make sense? And y'all are allowed to pull up a standard deck of cards if you need to on the test. Okay, this says a soda pop company is running a bottle cap contest where winner is printed underneath random bottle caps. If the probability of getting a winning bottle cap is 4, 6, and 4, what is the probability of not winning? So the probability of winning is 6 out of 40. And this is something we didn't cover too much. To find the probability of not winning, you just say 1 minus the probability of winning. Does that make sense? You'll always do that. If they give you a ratio or whatever of the chances of winning, like they said it was a 6 out of 40 chance of winning, to find the probability of you not winning, you just say 1 minus whatever the probability that they gave you. And so when you do that, I feel like I should do that on, I'm going to work it out for the ones that don't have calculators at home. So this would really equal 40 over 40 minus 6 over 40. And the reason that one change, do y'all understand how I got 40 over 40 for that one? So I only use 40 because whatever number's on the bottom of that is what you would use. Like if that was a 20, you would put 20 over 20. Because like if you look at this, 40 over 40, 1. 20 over 20. Doesn't matter how big the number is either. A number over that same number equals 1. So if you have a 1 minus a fraction like we have here, to get that same denominator, you put 40 over 40. Does that make sense? So if that was a 20, you would put 20 over 20, and then that would, so that you can subtract. So 40 minus 6 is 34, and then you just fall over with the denominator. So 34 over 40. What do we see about these numbers though? 34 and 40. They're even, right? So I'm going to try to divide by 2 and see if that will give me an answer that can't be simplified anymore. So when I do that, I get 17 over 20. And 17 and 20, they don't have anything in common. So that's the answer for that one. Does that make sense?
Yes.
Okay. So that's simple probability. Let's go on to this next, which is theoretical versus experimental. So theoretical meaning what you think would happen, and experimental is what actually happens when they do it. So the 12-sided die to the right is rolled 75 times. They will always tell you how many times it's rolled. Hold on, guys. The phone's ringing now. Hello. Yeah, I'm going to do it with you. Uh-huh. She was on there. Well, I guess she might have left, but she was on there. We were working right now. I mean, I'm recording this. I'll just keep trying, but never yell. I'm so sorry, guys. Okay. Okay, so what is the theoretical probability of the die landing on a prime number? Prime number, I get prime and composite numbers confused. I just want to double check. Okay, yeah, that's what I thought. Prime numbers are numbers that are only divisible by 1 and then that number. So like, say the number 7. What numbers divide 7? 1, 2 doesn't, 3 doesn't, 4 doesn't, 5, 6, and then 7, right? So 1 and 7. So 1 and the number itself. That's what a prime number is. Hard to remember. Again, even I have trouble remembering the prime numbers. But that's what the prime number is. So a prime number, let's see. Do they count 1 as a prime number? I don't think they count 1 as a prime number. So 2 can be divided by 1 in itself. So 2 is a prime number. 3 is only divisible by 1 and 3, right? 4 though, 4 can be divided by 1. 4 can be divided by 2, and 4 can be divided by 4. So that's not a prime number, right? 5, prime number. 6, it can be divided by 3 as well, and 2. So it's not 7, 8, 9, 10, 11. And 12 can be divided by. So 1, 2, 3, 4, 5. 5 numbers from 1 to 12 are prime numbers. So the theoretical probability would be a 5 out of 12 chance. That's what you think would happen. There's only 5 numbers that are prime. So 5 out of the total number, which is 12. Okay, so that's theoretical. Okay, so then it says, based on the experiment, what is the probability of the die landing on the prime number? So now we actually have to look. So let's look underneath the numbers that I circled. It landed on it 7 times, landed on 3 10 times, 5 9 times, 7 5, and then 11 7, and all that's over 12. So I'm going to add those together because that's how many times it actually landed on those numbers. It landed on 1 4 times, 2 7 times. So I need to count the ones that are prime. And I get 38 out of 12. Oh, my bad, guys. Not 12. 75, because remember they rolled it 75 times. So on theoretical, you're going to use the like here 12, but on the experimental, you're going to use however many times they actually rolled the dice. That was a mistake on my part, sorry. So 38 over 75. And those numbers can't be simplified. A 2 doesn't go into 75. 5 doesn't go into 38. So that's your answer. Okay, the next one says, theoretically, if the dice is rolled 400 times, how many times would you expect it to land on a number that is at least 5? Okay, so at least 5. So when it says at least 5, it does include 5, right? It just has to be at least 5. So 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. So an 8 out of 12 chance. I'm going to see if they put this question on the test because I don't like that. Again, I didn't make this test. Dillinger made it, and we all have to give the same test. So let me make sure she didn't put anything like that on there because we're going to skip that question if so. Because then it's wanting you to solve for X, doing the 400 times. Let me see. because I'm not going to go over something with y'all, honestly, if y'all are going to have to know what a prime number is. Yeah, she didn't ask that question. So we're not gonna do this one. I don't like that. So we're gonna skip these. So the theoretical and experimental, just based on this one problem right here, did it make sense? Theoretical, you just look at what you would think. So like, there's only 12 numbers here, so 12 is the total number. And then let me count the prime numbers, which we said was 2, 3, 5, 7, and 11. So 5 out of 12 is what we think would happen. But when they actually did the experiment, they landed 7 times on 2, 10 on 3, and so on and so forth. So we just added those together. And I put that over the actual amount of times they did the experiment. Do y'all understand why I put 75 on the bottom here and 12 on the bottom here? Theoretical, you're always just going to put, like, if I say, what are the odds I would land on a 2 or 3 when I rolled a die? Well, there's 6 numbers on a die, right? So the chances I would get a 2 or a 3 would be a 2 out of 6 chance. So you just use the number of outcomes you can have. You can only have 1 through 12 here, but with the experiment, you put the amount of times that they did the experiment. Okay. So, and there's not going to be one like that where they want you to do all that work. This is the work for it. So they got the 8 out of 12 like we got, because at least 5, 6, 7, 8, 9, 10. There was 8 numbers out of the 12. They simplified it, dividing by 4, and you get 2 over 3. But that wasn't the question. The question was, how many times would you expect to land if it was rolled 400 times? So they take that simplified fraction, equal it to x over 400, and you see it's just, we're not doing it. I just wanted to show y'all that. So the next thing is the counting principle. It says how many different outfits consisting of a pair of pants, a shirt, and a tie can be made of 4 pairs of pants, 7 shirts, and 5 ties. So when you're trying to figure out like different outfits with a certain number of clothing items, or like different coffee flavors with a certain amount of pumps and creamer, I don't really know how a different example, but all you have to do is take however many. So they said 4 pairs of pants, so I'm going to put a 4. They said 7 shirts, so I'm going to put a 7, and they said 5 ties. I'm going to put a 5. And when I do that, you just times them all together. So 140. So you can make 140 different clothing combinations with this amount of clothing items. Does that make sense? Okay. So this says a 2-story mall has 7 entrances on the first floor. Inside, it has 4 escalators, 9 set of stairs, and 2 elevators for customers to travel between floors. If a customer is on the second floor, how many ways can they leave the mall? So, count 4. So it's saying it has 7 entrances. So that's one number. And then it kind of goes into and then it says it has 4 escalators, 9 set of stairs, and 2 elevators. So, and it's asking about how many ways can they leave the mall. So what you do, because elevators, escalators, and stairs, those aren't like exits, right? Those are just ways to get from point A to point B. So what you're going to do is add those numbers up. So 4 plus 9 plus 2 is 15. And you times that by 7. There's not going to be one like this on the test. But I do want to like go over it with y'all. The reason I added those numbers up because it's asking for ways they can leave the mall. But escalators, stairs, and elevators are not ways to exit a building, right? They're just ways to go from the floors. So that's why we added them together and we times it by the actual entrance, like the way the person can leave the mall. And once you times that together, you get 104. No, 105. 105 to leave the mall. So you can come in, exit 1, go down an escalator, go up an elevator, and then leave. And then there's a lot of different ways, right? So. Okay, this one says a standard die is rolled twice. Then a card is chosen at random from a standard deck of cards. How many outcomes are possible? So a standard die is rolled twice. So 2 times 2. Then it says a card is chosen at random. How many cards did I say was in a deck? 52. Times that by 52. And you get 208. So the counting principle is pretty easy. All you have to do is times the numbers together. So, pretty sure this one was either on the test or on the review. It says a company gives a client a unique account number containing 4 letters followed by 3 digits. How many account numbers are possible? So it's saying containing 4 letters. So four letters. So how many letters are in the alphabet? Anybody know off the top of their head how many letters are in the alphabet? So I'm going to write this down and I want you to tell me if you understand how I got that. There's 26. Yeah. Okay. 26. Do y'all know why I put 4 26s?
Why?
It says 4
Just
letters.
here for letter.
So I have to take into account the letters 4 times. And then it says followed by 3 digits. How many digits can you get? And then, like on a car tag, how many digits can you get? You can get a 0, a 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it, right? Because 10 is just a 1 and a 0. We already have that, right? So 10, right? So times it 10, 3 times. So I did 26 because that's how many letters are in the alphabet. And it's asking for letters, but to begin with. And they say they can get 4 of them. So that's why I did 26 times 4. Because in the 26 letters here, I can get an A. 26 letters here, I could get a Z. Here, I could get a G. And here, I can get an H. And then for numbers, you times it by 10 because I can get a 0 here, a 7 here, and a 9 here. Does that make sense? So if you see any kind of problem where they say, you know, a company's given account numbers, they can have 3 letters and 4 numbers. If it said 3 letters and 4 numbers, you would times the 26 3 times and then the 10 4 times if it said that, right? Does that make sense?
Where you get 26 from?
That's how many letters are in the alphabet. Let me I'm more than husband. Let me just Google it real quick. Because I know a lot of y'all said 24. Yeah, 26. 26 letters. And you might want to tell me if that does make sense, doesn't make sense. So I'm going to times these together on my calculator. And you get a really big number. I don't even know where to write it. 4, 5, 6, 9, 7, 6, 0, 0, 0. I know that's not the best. This is the answer. So there is literally 456 million and then some numbers, account numbers that people can have. So that's how people never have the same account number because there's so many different variables in it. Hopefully that makes sense. Looking at this earlier, I don't really like how this chart is set up. It's honestly kind of confusing. Okay, I see. I guess I just didn't read. So it's saying the white background are positive. The light gray or undecided, and then the dark gray are negatives. You see the difference in the colors. So it's asking for positive. You're going to ask it 2 questions, and you have to find the probability. So probability that it would give a positive both times. Let's count how many positive statements there are. They're in the white. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 positive. And then we need the total amount of outcomes, right? It said that it would give, you can either count all these spaces or just look up, it tells you the total number of outcomes, which is 20. So on the first chance, 10 out of 20. And then it's wanting positive both times. So all I do is times that again. And when you do that, you get 1/4. Okay, that one didn't make sense. Let's go into this one. Let's see if doing more will help understand. So it's wanting undecided both times. So undecided is the light gray. 1, 2, 3, 4, 5. 5 undecided options. And again, there's 20 total. And it's wanting both times as well. So just times it again. And when you do that, you get 1/16. And if you guys don't have a calculator, when you times fractions like this one would have been 100 over 20 times 20 is 2, 400. 400. All you do is multiply across. So 10 times 10. 100 is the top number, and then 20 times 20 is 400. And then that you just simplify. You could divide by 100. 100 divided by 100 is 1, and 100 divided by 4 is 4. So that's how you get 1/4. Here, again, you multiply straight across. Again, this is for people who don't have a calculator or like a scientific calculator where you can put stuff in fractions. So 5 times 5 is 25. And again, 20 times 20 is 400. So 25/400 divide by 25, and that's how you would get 1/16. But I'm able to just say and it gives me a simplified answer. But so if you don't have a calculator like this, you don't want to use Desmos, multiply straight across for fractions and then simplify. Okay, it's wanting a positive, then a negative. Okay, positive, we know there's 10 of them out of the 20. And the negative is the dark gray. 1, 2, 3, 4, 5. I'm going to times that by 5/20. So all you do for these is just times it by whatever thing they want. So like positive, write that first and then times it by whatever next they give you. Here was both times positive, so that's why we times it by the same thing. Same here. And then here it's different because they're wanting a positive, then a negative. And when you do that, you're going to get, if you multiply straight across, 50/400. I would divide by 50. And you would get 1/8. Last one for this problem with the chart. It says the probability of don't count on it then positive. So it's only asking for a statement. How many don't count on it do we see? Only see that one right here. And it might be kind of hard for y'all to see. So don't count on it is a 1 out of 20 chance, right? There's only one of them out of the whole 20. Then you would times that by the positive, which we already know from this problem, the positive is 10 out of 20. There's only 10 positive out of the whole 20. When you do that, 10 out of 400, so you would get 1 over 40. Did those make sense with that chart? Okay. Okay, let's go to the next one. If a die is rolled 3 times, what is the probability of getting a 2 on the first roll, an odd number on the second, and a number less than 5 on the third? So that was a lot of information, right? So let's break it down. So I know it's rolled 3 times. Probability of getting a 2 on the first roll. So what is the probability of getting a 2? So I have a dice, right? It has numbers 1 through 6. What are the chances of me getting a 2? How many 2s are on that dice? 1, right? So I have a 1 out of 6 chance on that first try to get a 2. Okay, let's go to the next one. It says an odd number on the second roll. How many numbers are odd on the dice? We have a 1, a 3, and a 5. So a 3 out of 6. And you're going to times all these numbers together. If it's wanting like, anytime it's asking for like, if I did this, what's the probability that I would get this on the first try and this on the second? You always times those numbers together. And then a number less than 5 on the third roll. How many numbers are less than 5? 4. 4 out of 6. And so you just times these numbers together. Again, if you don't have a calculator, multiply straight across. 6 times 6 times 6 is 216. When you have big numbers on the bottom like this, I recommend seeing if that top number will divide the bottom number. Let's see, 216 divided by 12. And it does. So I would divide by 12 on both of them. You would get 1 over 18. Make sense?
Yes.
Perfect. Okay, so next question. A pop quiz contains 5 true or false questions. If Emily guesses, what is the probability that she would guess all 5 correct? So we know there's 5. So that means I'm going to have 5 different fractions, right? Because again, the dice was rolled 3 times. I have for 3 different things. There's 5 questions. I should have 5 different fractions. So what are the odds of you getting a true or false correct? What do we always say when there's a true or false? You have a 50-50 shot, right? So a 1/2 chance of getting the answer right. And we know all 5 of those are true and false. So the chances of you getting all 5 of those true or false correct is going to be 1/2 times 1/2 and so on, 5 different times. So When you do that, you get 1/32. You have a 1 out of 32 chance to get all 5 of them correct, if they are true and false. Let me see. I know there was one either on the review or the test that said, from like the last test, it had like 2 true or false questions and then 3 multiple choice. If it throws in that multiple choice with it, so say here they had 2 true or false and then 3 multiple choice. I'm gonna kind of reword the question for y'all. So 2 true or false, but these would be 1/4, right? Because with multiple choice, you have a 1 out of 4 chance. Does that make sense? I kind of just want to throw that out there in case that question's on the test. Okay, the next problem. A bag contains the letters of the word Pennsylvania. A letter is drawn, replaced. That's a big word right there. I need us to remember that it is replaced. So like I have a bag of 10 candies. When someone comes and gets a candy, I put another one in there so it stays at 10 candies, right? So replaced is what that means. Then another is drawn. What is the probability that the first letter is a N or an A, and the second letter has a vertical line of symmetry? What in the world? I don't even know what that means, a vertical line of symmetry. Anybody know what that means? I mean, I get, but why would they even, I'll have to figure that out. 1, 2, 3, 4, 5. I feel like people's answers would vary on that. I mean, basically what they mean is like you have the letter A. You draw a vertical line in between that. The sides look the same. I'll just work it. So, the first fraction. Probability of getting a letter that's N or A. How many N or A's do we have? We have 1, 2, 3, 4, 5. 5. 5 out of 12. There's 12 total letters, right? So we had a 5 out of 12 chance of getting an N or an A. It is replaced, so there's still going to be 12 letters. If it said it was not going to be replaced, this second number would be 11. And we're going to work something like that down here. So that the second letter has a vertical line of symmetry. How many do they say? I'm going to say Y is 1, V is 1, A. They have 5. I guess you can include the I, or maybe the S wouldn't be it. I guess they're including the I. There's not one like this on the test. Anything about a vertical line of symmetry. Nothing like that. But I'm just going to guess that it's including that I, because N is not, L is not, E and P they don't look the same on both sides like an 8 would. So I'm gonna just go with what they have. I would say 4, but they said 5. And then of course just multiply straight across and simplify, and you would get, well, when you multiply straight across, actually 25 and 144 actually have nothing in common. This can be divided by 1, 5, and what else? Nothing that 144 can be divided by. So that's your answer. Did that make sense? Definitely not finishing halfway through, I don't think, today. Let me see. Let's do the next one. It says the varsity baseball team has won 15 out of the 16 games. So let's write that fraction down. They won 15 out of 16 games. And then the junior high varsity team has won their 6 out of 10. So what would be the probability that both teams win their next game? All you do is times that together. You would get 90 over 160 simplified by 10. Divide both numbers by 10, and you would get 9 out of 16. So they would have a 9 out of 16 chance of both of the teams winning. We took the probability, well, not the probability, we took like the ratio of their winning. So they won 15 out of 16, and then they won 6 out of 10. Now, if this would have said they lost 15 out of 16 games and this team lost 6 out of 10, and it still wanted to know the probability that both teams would win, we would need to find, so that would be 1 out of 16 that they won, and then this would have been 4 out of 10 that they won. So we would have times those together. So make sure that it says like this is the ratio that they won and not lost. I hope that didn't confuse anybody. And I guess I'll start with 14 tomorrow. Probably going to skip some of this mean, median, and mode and range. I feel like this, y'all should know that. Y'all let me know if y'all think differently. We don't. Yeah, I'm going to just stop right there. If you want to know if you're missing any work, stay on and I'll let you know. But if you know you don't have any work, you're good to go. Be here tomorrow, and we're going to finish going over the review.